Okay? So the first part of this is going to be directly done onto this paper. Put that phone away before I take it away. And then second part is going to be done by using tracing paper, the patty paper that you're going to get, okay? You're going to need about 4 different colors, okay, when we do the patty paper. So let's get started. You can even use different colors right now if you like. So I'll start with our radians. So if I have 0 degrees, that would be 0 pi. From 0 pi to 180, what's the radian for that? What's the full 180 would give us an equivalence of 1 pi, right? Then what's the halfway point between the two? 0 to 180, what's the halfway point? 90. So this is half of pi. Okay? If that's half a pi, and if I have 2 halves, I get a whole pi, right? Another half pi would make it?
Pi and a half.
Pi and a half, which is same as 3 half pies. Yeah? 3 over 2. And then the last part right here, if I were to have another half a pi, that 360 would be 2 pi. How you doing? Pretty easy? Okay. This is called a unit circle because this is the very foundation of trigonometry's angle measurements. And the unit that we're talking about is typically just the ratios that we're talking about, the bare minimum ratio, okay? So from the origin to this given point on the edge of the circle is going to be 1 unit away from the origin and 0 units moving up or down, right? It's just the order pair, x and y. Yeah. I'm using it for the same color for all the 90s. But it's up to you. Whatever you want to do. Okay? Then the opposite side to 1, 0 at 180 would be negative 1, 0. Is that making sense so far? Okay. And from the origin, if I don't go right or left and I go straight up, what would be my x and y value? 0, 1. You guys doing okay? Pretty easy so far, right? Directly below it, the same number unit down would make this 0, negative 1. Doing okay? All right. Now, let's try 45 degrees. The reason that these are in dashes is because it's not because I wanted you to connect the dots, but rather because it's not really there. Okay? It's not really there, meaning like it's supposed to be the radius. It's just a simple distance from the origin to whatever point we're at. Okay? So in this case, this is 45 degrees. So what's half of a half? 1/4, right? So a quarter. So this will be pi over 4. Then if I have 2 quarters, that's equivalent to 2 pi over 4 is equivalent to pi half, right? Pi over 2, pi half a pi, yes? Okay, and then another quarter to that half would make it 3 pi over 4, or 3/4 pi, right? Then 1 more quarter would make it 4 pi over 4, which is pi, just 1 pi, right? Are we okay so far? Add another quarter to that, 4 pi over 4. What would that be? This would be 5 pi over 4. Yes? And then 1 more quarter would be 6 pi over 4, which is same as, simplify 6 pi over 4. 3 pi over 2, right? So it's the same thing. This is the same thing. Yeah? Are we okay so far? Okay. Another quarter added to my 6 pi over 4. What do you get? 7 pi over 4 is at 315. Then another quarter added to that would get me 8 pi over 4, which is same as 2 pi. How you doing? Pretty good? Okay. Oh, forgot this part. Okay. Now, I'm going to highlight the 6. I'm going to do it in blue. Okay? So, if I were to cut this pizza, just a half of a pizza, here's half a pizza, from 0 to pi, this is 30 degrees, right? Here's another 30 degrees. Here's another 30 degrees. Here's another 30 degrees. And here's another 30 degrees. So far, so good? How many pieces of pizza do we have? 1, 2, 3, 4, 5, 6. Yes? So 30 degrees is 1/6 of a pizza. So it'd be pi over 6. Okay, so far so good? Then if I get to 60 degrees, another 30 degrees added, another 1/6 of a pi added, I would get 2 pi over 6. I'm going to put that in parentheses. You know why? Can I simplify that? Yep. We're going to simplify when we go over the 60s. Okay? Another 6 would make it 3 pi over 6, which is same as half pi. So far, so good? So this is same thing as 3 pi over 6, right? And then another 30 degrees would give me another 1/6 of a pi, which would give me 4 pi over 6. You doing okay? Another 30 degrees would add another pi over 6. So that would make it 5 pi over 6. That's 150 degrees. Another 30 degrees would make it 180. And that would be same as 6 pi over 6, which makes it a whole pi. You doing okay? Okay. So here's the other half right here. 30 degrees, another 30, another 30, another 30, and another 30. Okay, but we're still going in 6. Okay, we're still going in 6. So one more 6. Label the next one. Okay, so this one would be 7, highlighter, my bad. 7 pi over 6. Do you see why I skipped 6 pi? Yes, okay. And then 7 pi over 6, then what's the next 30? 8 pi over 6, but I'm putting that in parentheses because there's a third equivalent, okay? And then another 6 would give me, what would it be? What would it be? 9 pi over 6. If I reduce it with 3, it'd be 3 pi over 2, which is the same thing as that, right? You doing okay? Okay, 9, and then what's the next number up? 10 pi over 6. That I can reduce with 2, so I'll leave it like that in parentheses. Bye, Abby. And then another 6 would add from 300 degrees to 330, making this 11 pi over 6. How you doing? Okay. Now we're gonna do, I'm gonna erase all this. Okay, I'm gonna do 6. Okay, 60 from here. And then another 60 would have me be at 120. Another 60 would land me at 180. So how many pieces of pizza do you see here? 1, 2, 3, right? So each 60-degree is split into
Thirds.
thirds. So watch this. If I were to simplify 2 pi over 6 with 2, that would be pi over 3. Ta-da! Pi thirds. Okay? Another third would make this 2 over 3 pi. 2 pi thirds. You guys doing okay? Are you lost? Are you okay? If you need me to erase this, I can. Would that make it easier for you to see it? Are you lost? Okay. Do you want me to erase it or not erase it? Erase it? Oh, to keep it. Okay. All right. Then another third would land me at 180. So that would give me 3 pi. This is the same thing as 3 pi over 3, right? Same thing as 1 pi. What's next? I'll highlight the others. Here's another 60 degrees. And then, oops, another 60 degrees here. Here, right? So it's still in thirds, right? We don't put it out of 6, we take it out of thirds because from 0 to pi is broken into thirds, okay? So another third would make this equal to 4 pi thirds, okay? Another third added to that 4 pi thirds, you would get 5 pi thirds, and those are equivalent, right? 10 pi over 6, same thing. Okay, and then the last one would be 5 pi thirds, so it would be 6 pi thirds, right? So 6 pi over 3 is same as 2, right? Does that make sense? All right. This is the point where I give you tracing paper. You ready? One color per quadrant. Okay, you ready? We're gonna do 30 degrees. What's the shortest sides ratio for 30 degrees? 30, 60, 90. 1. Is that climbing up to positive 1 direction or climbing down? Up. So that's positive 1. Okay. What's the hypotenuse length for the 30, 60, 90? 2. And radius is always distance, so it's positive. Radius is the only thing that's going to always stay as a positive value, okay? Then the distance from the origin to the base of this 90-degree angle is going to be rad 3. Are we okay so far? So what's the ordered pair here? Well, it should be read. I'm going to have you write this on the side, put a star on it, okay? It's always read as cosine of any angle is your x value, because the adjacent side is the reading of the x value, right? Does that make sense? Adjacent side, remember it's adjacent over hypotenuse, yes? So that's adjacent side is your x value. Does that make sense? Sine of theta is going to be your y value in this ordered pair. Okay? So what's the cosine of 30 degrees here? Rad 3 over 2. That's your x value. What's your sine of 30 degrees? 1 over 2. So 1 over 2. Look at that. Do you see how it's identical there? That's how they get it. Those points are how you get that ordered pair. Okay? Are we okay so far?
Wait, yeah, when did we write those numbers?
Just now, something.
What do you mean? You didn't. You didn't. You're supposed to write it in as we're tracing. Write it in.
So is it supposed to go on the tracing paper?
This goes on the tracing paper. So you can use this for any problem that you encounter that has 30 degrees. And then I'm going to make one for 60 degrees. And then I'm going to make one for 45 degrees on separate sheets of paper. That's why you have 3. Make sense? Okay? So you don't have to worry about reflecting, transforming, or whatever, twisting it around, rotating. You have all 4 quadrants covered with each of the 3 special angles. Does that make sense?
Oh.
Okay? I'm giving you a helpful thing. Just trust me. Just trust me. If you don't get it, just trust me. Okay? All right. We're going to do quadrant 2. Pick a different color. Okay? So I need a reference angle with the x-axis. We're only doing reference angle of 30s for this paper using the x-axis. So here's my side. What is wrong with all my markers today? I'm dying here.
Adjacent over hypotenuse?
Yes, adjacent over hypotenuse is what I meant there. Maybe it'll work on this side. Maybe it's because of that. Okay. All right, here we go. So we're going to go from the origin and measure out to 150. You good? Drop it down, straight down to make a right triangle. Okay. Again, this is your 30 degrees. Wow, that looks awful. Let me use black for that one. 30 degrees right here. Okay. What's the opposite side to 30 degrees? Is that the shortest or the longest side? Shortest. So I'm going to write that as 1. Then which one is my hypotenuse? The one on the x-axis or the radius to the peak of the triangle is my 2. Then what's my length for the adjacent side?
Negative rad 3.
Rad 3, but it has to be negative because from the origin, if I go to the left, it's negative, right? Does that make sense so far? Okay. So what's my ordered pair for this particular point? Negative rad 3 is the adjacent over 2, comma. The y value is sine of 30. So what's the opposite side over? 1 over 2. That's the location of that point. Okay? Are you doing okay now? No? Still no? Okay. It'll get better. It'll get better. Okay. Pick another color. Okay. Pick another color.
No one smudged it.
No matter what angle it is, the ordered pair for the top of that point at the end of the radius, that makes the 90-degree angle, is always going to be cosine, comma, sine. Always, no matter what the angle is. Inside angle is my reference angle. Yes. Yeah. Yeah, I know. That happens because my students are really mean to them. Just toss it so ink doesn't get all over you. Okay? All right, so my 30 degrees from 180 is going to be 210, so I'm going to follow this line. Okay? Make a 90-degree angle with that. And there should be a right angle right there. Okay? Then the shared x-axis right here is also going to be negative rad over 3. Yes? What's the shortest side going to be to my 30 degrees reference angle here? -1. This is my 30. My fine points do not like these tracing papers. 30-degree angle there. And then this would be -1. Yeah? Then what's my radius here? 2. It's still positive because it's the distance from origin to that point. Okay? It's not talking about the ordered pair, we're talking about the distance. Okay? So, if I were to write an ordered pair for this one, what's the cosine of 30 degrees for this reference angle? -rad3 over 2. Pretty weird, but it's right. And then the y value is going to make the differentiation between this orange point and the blue point, right? So what's my
-1 over
sign? -1 over 2. That makes the difference between these 2 points. Yeah.
How come the 2 wouldn't be negative?
It's the distance from 0, 0 to the top of the point. It is not the coordinates for it. Yeah. Okay. Are we good now? Okay. Last one. Pick another color. Last color. I told you you needed 4, right? Okay. The last one should be at 3:30. So follow the line, graph it, or trace it rather, from the origin. Right there. I'm almost to making a hole there. Oopsie daisy. Okay, there we go. Okay.
The pink one is like.
The shared initial side is going to be still positive rad3. Then what's the short side? -1. And then this long radius side is still 2. Then what's this ordered pair here? It should be cosine rad3 over 2. And the sign should be -1 over 2. Ta-da! See? If I just told you what the ordered pairs are without showing you why we got those numbers, you'd be completely lost and wondering, how am I supposed to memorize this? You don't need to memorize it. If you know one triangle, you know all 4 in every quadrant. Does that make sense? Okay, we're going to switch our paper.
Wait.
Okay, waiting.
It's a black widow. Thank you.
We're going to switch our paper so we can do the 60s. Okay, we're going to do the 60s. 60-degree angles. I'm going to label this as my 30-degree or pi over 6. Okay, at the very bottom, I'm going to label it like so. Okay, oh, don't forget your name. So you can get it back in case it gets lost. This is my name, people. Don't write my name on yours. Okay?